Hello friends, welcome to our channel redsinfohub. I am Mr. Redappa Taniru. Now we are discussing in a chapter moving charges and magnetism. In the previous sessions we have already discussed about what is the Biot-Savart law, and one of the applications of it is how to find the magnetic field due to a finite straight current carrying conductor. Right, I hope you guys have understood. Now in this session, let us see few examples and then some special cases related to this particular concept. Are you ready? Yes, open a pen and paper and start along with me. Yes, first, let us try to recollect back what is the formula to find the magnetic field due to straight current carrying conductor. If you have a straight current carrying conductor, in this current I is flowing at a point P, if you are asked to find magnetic field, you have to draw a perpendicular line, and if you connect the top point to the top point of the conductor to this point and bottom point of this conductor to this point, so that they are making angles alpha and beta with respect to perpendicular line. Alpha and beta with respect to perpendicular line. From the perpendicular line, try to follow this particular point carefully. Then, and if the point is at a distance, perpendicular distance d from the current carrying conductor, then magnetic field due to this entire conductor at this point is mu naught I by 4 pi d, the perpendicular distance, into sine alpha plus sine beta. If you consider this angle as alpha and beta, if you consider this angle as theta 1, theta 2, sin theta 1 plus sin theta 2, accordingly you have to follow. Is it clear? Now, let us do some examples based on this, then we will discuss some special cases. Example 1 is, the question is, find the magnetic field due to a straight current carrying conductor at a point P, so that this top end, the line joining from top end to the point is making an angle of 60 degree, and the line joining from bottom end to the point is making an angle of 30 degree. Then, provided the distance is d only, we are not giving a numerical value for this current, and the distances are represented as I and d only the angles are mentioned. So find the magnetic field due to this conductor at this point. So we have to use the generalized formula. What is that? B is equal to mu naught I by 4 pi d into sin alpha plus sin beta. Here first you have to note down what is alpha and what is beta, what is d. Then you can substitute and find the total field. What is alpha here? Alpha will be measured from this perpendicular line onto this line. So it is 60. Alpha equal to 60 degree. And beta is equal to beta from perpendicular line, this. The angle from here to this one, it is 30 degree. And what is the perpendicular distance? D is given as d only. If you substitute this over here, then what will you get? B is equal to mu naught I by 4 pi d into sin 60 plus sin 30. Is it clear? Then, what is sin 60? Yes, very good. Sin 60 is root 3 by 2. Sin 30 is, yes everyone, very good. Sin 30 is 1 by 2. Right, if you substitute these values, then you will get the expression mu naught I by 4 pi d into sin 60 is root 3 by 2 plus sin 30 is half, 1 by 2. Now, as bases are common, if you simplify this further, it becomes root 3 plus 1 by 2. So, we can write this as root 3 plus 1 by 2 times mu naught I by 4 pi d, or root 3 plus 1, root is only for this 3, root 3 plus 1 into mu naught I by 8 pi d also you can write. Depending on the options, you have to rewrite that final answer. Is it clear? So what is the expression, what is the value of b now? B equal to mu naught I, root 3 plus 1, root 3 plus 1 by 2 into mu naught I by 4 pi d. Usually don't cancel this or multiply, just don't change this factor of mu naught by 4 pi by doing numericals. because we know mu naught by 4 pi value is 10 to the power minus 7. So it is easy to substitute and simplify while doing the numericals. So try to retain this and simplify. Is it clear? Yes. Take a screenshot if you want. And especially if some of you are using auto typing words, if they are displaying, try to hold finger on the screen so that while taking a screenshot or while copying, those lines may block some of the lines over here. If you tap your finger on the screen, that automatically typing letters or sentences will stop displaying on the screen. Is it clear? Yes. Have a note of it. Let us go to the next example. So let us see next example. Find magnetic field B at a point P from the figure, or shown in the figure. The figure is this. We have a straight current carrying conductor in which current I is flowing. The point is lying here, which is at a distance A as shown in figure, so that the top end of the line drawn from the top end to this point is making an angle of 30 degrees with this line, and the angle between the line drawn from bottom end to the point is making an angle of 30 degrees with the horizontal. Is it clear? Now in such case, how to do? Usually the general formula to find the magnetic field due to straight current carrying conductor is B is equal to mu naught I by 4 pi d into sine alpha plus sine beta, where alpha and beta are the angles measured from perpendicular line to the line joining from top end and to the line joining from bottom end. You have to remember that. Now here you have to write what is alpha, what is beta, and what is d. What is alpha? Here you know that if you observe the previous one, if this is a straight current carrying conductor, this is point P, perpendicular line is this, and this will be alpha, this will be beta. Here alpha and beta will be measured from perpendicular line, right? Anti-clockwise and clockwise. Here the angle between that perpendicular line and the line joining from top end to the point is alpha. So here what is perpendicular line to the conductor? Here, because the point is lying here, let us extend this conductor and let us draw this as a perpendicular line from conductor to the point. From here you have to measure the angles. Keep this point in mind, everyone. Is it clear? Now from here to here is alpha. What is this from here to here? This is 30, this is 30 it is given. So from here to here total is 60. That angle is our alpha, total angle. So in this case alpha is 60 degree. It is measured in anti-clockwise. What is beta? Beta is the angle between the perpendicular line and the line joining from bottom end to the point. Bottom end is this, point is this. So the angle between perpendicular line and this measured in anti-clockwise. From this in anti-clockwise you have to measure. That is your beta. But here this angle is given as 30. This is not an anti-clockwise but in clockwise. So you can remember that if you measure like this in clockwise, you have to take this as minus, negative. Is it clear? You have to take this as negative if you are measuring in anti-clockwise direction. If you are measuring in clockwise, because while doing the derivation we have taken in the proper order, that's why you have got in this formula plus. If you take in the same sense, then it will be minus. In this case you have to take beta equal to minus 30. Otherwise we can take this angle as 360 minus 30 is the angle between this and this line. So it is 330. 360 minus 30 is equal to 330. In this way also you can take 360 minus 30. 360 minus 30, because 360 minus 30 falls in fourth quadrant. If you remember this first quadrant, all positive, all silver teacups, all trigonometric angles are positive in first quadrant, second quadrant only sign positive, third quadrant tan positive, here was positive. So by taking this into consideration, here in sine 360 minus 30 if you take it becomes negative, so minus sine 30 will get. In that way also you can do it. So 360 minus 30 or minus 30 directly you can take. Is it clear? So D, what is D? Perpendicular distance from the conductor to the point. This is given as A, so it is not given. This is your this is the distance what you need. So it is equal. This is A and the angle is 30. So it is a cos 30. So your d is equal to a cos 30, a cos theta here, that is 30. Is it clear? D is equal to a cos 30. Right, but cos 30 is root 3 by 2. So root 3a by 2 is your d. Substitute these angles in this formula, then you will get the final expression. So what is b? So from this you can say that b is equal to mu naught I by 4 pi. D is root 3a by 2 into sin alpha plus sin beta. Sin alpha is sin 60. Sin alpha is 60, so sin 60 plus beta is sin 360 minus 30. Sin 360 minus 30 is minus sin 30. So you can write directly minus sin 30. I hope you guys have understood how to get this. Sin of 360 minus 30 can be written as minus sin 30. Right. Next, it is equal to, if you take this 2 up, you will get 2 mu naught I by root 3 or 4 root 3 pi a to sin 60 is root 3 by 2 minus sin 30 is 1 by 2. So again, if you simplify this further, root 3 minus 1 by 2, 2 to cancel. So you get root 3 minus 1 to mu naught I by root 3 to 4 pi a. This way also you can write. This is your magnetic field. Is it clear? Yes? Copy it and try to go through step by step. Try to understand. Now let us see another example. Yes, let us see another example. See, as a generalized formula, even for the previous kind of problem, find B, that is magnetic field for a current carrying conductor in which current I is flowing upwards and a point is lying at a point is lying at a distance A from the conductor as shown in figure, provided the line joining from top end to the point is making an angle theta 1, this and right, and this angle between the line joining from bottom end to the point is making an angle of, so this angle is from the horizontal, you can say, is making an angle theta 1. From this horizontal, it is making an angle of theta 2. In this case, find the magnetic field at this point due to this conductor. In such case, you can use this as a generalized formula for the previous kind of problems. In this kind of case, what you have to do is you have to extend the line or axis of this conductor, and you have to treat this line as a perpendicular line, and this perpendicular distance you have to take this as d. This d is equal to, because this is a and this is theta 2, the angle between this line and the perpendicular line is theta 2. So this you can take it as what? A cos theta 2. D is equal to a cos theta 2. Is it clear? Next, so here, as I told you, as general, you have to write the general formula for any straight conductor. B equal to mu naught I by 4 pi d into sin alpha plus sin beta. Here, what is alpha, what is beta, and what is d? Alpha is the angle. If you just again recollect back, this will be alpha, and this will be beta, and this is d. Alpha is the angle between perpendicular line to this line, that is here our theta 1. So alpha is equal to theta 1. Beta is the angle between perpendicular line and the line joining from bottom end to the point. This angle, this is your beta actually speaking. So it is 360 minus theta 2. Are you following? D is equal to a cos theta 2. Now if you substitute over here, you will get B is equal to mu naught I by 4 pi d into, yes, sin theta 1, alpha is theta 1, plus sin 360 minus theta 2. Right? If you simplify further, you get mu naught I by 4 pi, yeah, d is a cos theta 2, a cos theta 2 into sin theta 1
plus here sin 360 minus theta 2 becomes minus sin theta 2. So this is something like sin 360 minus theta, or sin 360 plus theta. So 360 plus theta is sin theta, but 360 minus theta is minus sin theta. So it is minus sin theta 2. This you can use as a generalized relation in this kind of cases. Here theta 1 can be 60 or 45 or 30, whatever it is. Theta 2 also in same way can be of any angle. Okay. Yes, have a note of this. Special cases. Special cases as examples itself. You can take those as special cases or examples as well. So find the magnetic field at a point which lies along the length of the conductor. You can, if you want, you can write it as a question. So here, this is our current carrying conductor in which current I is flowing. The point is lying over here. This is the length of the conductor along the length of the conductor. In such case, what is the magnetic field? If the point is lying along the length, maybe to the right or to the left also. To the left also. You can take this as one case. Other case is current may be flowing in this direction or in opposite direction. Point P may be here, or you can take this A, B and C. These are not options. For in all these cases, magnetic field will be same. What is that value? That similar value, what is that? We are going to see now. If this is the conductor, in this current I is flowing at a point P here. Due to this, what is the magnetic field here? And if you have, this is the current carrying conductor in which current I is flowing, at this point P, what is the magnetic field? In all these cases, actually the total magnetic field due to straight current carrying conductor we have derived as B equal to mu naught I by 4 pi d into sin alpha plus sin beta, even by, that is by using Biot-Savart law, right? According to Biot-Savart law, we have divided this entire conductor into small element, and field due to the small element in vector form is mu naught I by 4 pi d into dl bar cross r bar by r cube, or dl bar cross r cap by r square. Here itself, if you observe, if you consider any small element of length dl, okay, current element direction will be along the direction of current. This is the direction of current, and r bar is the distance of this point from this element. Then if you draw a line with an arrow, this is r bar. Here dl bar is this, r bar is also in same direction. So the angle between them is theta is 0. In this case, theta is equal to 0. If you consider here an element, because current is flowing in this direction, dl bar will be in this direction, right? And r bar is this, is your r bar. So they are in opposite directions. In this case, theta is equal to 180. So this further you can write as mu naught I by 4 pi d. Mu naught I by 4 pi d into dl bar cross r bar is dl r sin theta by r cube. R cancel, of course. Here theta is angle between dl bar and r bar. In this case it is theta, in this case it is 180. So sin 0 or sin 180 is 0. And here also if you see, because here in this case, if you observe, dV is equal to 0. Why? As theta is 0 or 180, sin 0 or sin 180 is 0. Here also same, if it is lying over here, theta, in this case this is dl bar, this is r bar. So theta is equal to 0. Here this is dl bar and r bar is this. So here theta is 180. In these cases as well, dB is 0. As dB is 0, if you want to find the total field due to the entire conductor, if you integrate, B equal to integral of dB equal to 0. Yes, is it clear? This is the case which we have discussed in the previous video. That is, if the point lies along the length of the conductor, along the length of the conductor, then magnetic field, then B is equal to 0. Why? Because theta is equal to 0 or 180. So dl bar cross r bar is equal to what? 0. That is dl r sin theta is 0. I hope it is clear for you guys. Next. Yes, next. If the next case, if the point is such that the wire is of finite length, if the wire is of finite length L and the point is on its perpendicular bisector, how it looks like is, this is the conductor. The conductor is having finite length L. Let us say this is the finite length of the conductor, and in which current I is flowing, and the point is lying on its perpendicular bisector. Means exactly bisector. Bisecting point means midpoint. If you draw a perpendicular line at its midpoint, at somewhere here P, such that the line joining from the point to the conductor is like bisecting this conductor into two parts equally. That means this will be half of the length and this is half of the total length, L by 2 and L by 2. Then what is the magnetic field at such point is the question. In such case, the angle between the line joining from top end to the point and from bottom end to the point, if you say this is alpha, this is beta, in such case alpha will be equal to beta because it is divided equally. Are you following? If the point is lying on its perpendicular bisector, then this perpendicular line divides this into equal parts, L by 2, L by 2, then alpha will be equal to beta. Then what is the field? From general formula, B is equal to mu naught I by 4 pi d into sine alpha plus sine beta. Here alpha is equal to beta, this becomes sine alpha plus sine beta to sine alpha. And here this, let us say this distance is, perpendicular distance is d. And then you can write it as mu naught I by 4 pi d into 2 sine alpha, 2 sine alpha. But what is alpha here? This is L by 2, this is d, and this is the distance between the top end and the point. Let us take it as r. By applying Pythagoras theorem, it will be hypotenuse square is equal to side square plus side square, or this is equal to square root of this square plus this square. That is square root of L by 2 whole square plus d square. It is equal to L square by 4 plus d square, or L square plus 4d square by 4 under root. But this you can write root of this by root 4. Root 4 is 2. So you can write this further as this is equal to square root of L square plus 4d square. Root is only for that numerator divided by 2 is your r. Got it? So from this figure, you can take sine alpha as sine alpha equal to opposite side by hypotenuse. So from figure, sine alpha is equal to opposite side is L by 2 by hypotenuse is r. That is this one. Square root of L square plus 4d square divided by 2. 2 to cancel. So this is equal to L by square root of L square plus 4d square. Is it clear? By substituting this over here, you will get the total field B is equal to mu naught. 2 into 2 is here, right? You can simplify this or you can keep as it is. 2 mu naught I by 4 pi d into sine alpha is L by square root of L square plus 4 d square. Right? You can simplify or you can keep as it is, because mu naught by 4 pi will give you a numerical value of 10 power minus 7. It is easy to calculate the values. Right? So this is the expression for magnetic field due to a finite wire of finite length L. Got it? Yes, for those actually here the sin alpha was not displaying properly. This I am writing clearly over here. And sin alpha is opposite side by hypotenuse. It is L by 2 by hypotenuse is this square root of L square plus 4d square by 2. This is denominator. Denominator and numerator 2 cancels, so you will get sin alpha is equal to L by square root of L square plus 4d square. And this sin alpha we will substitute here, so we will get this one mu naught I by 2 pi d. 2 into mu naught I by 2 pi 4 pi d into sin alpha is that one. Is it clear now? Yes, let us continue with the next example. Yes guys, let us start with next application. The next one is Magnetic field due to infinite current carrying wire. Infinite is very important. Based on this kind of infinite and semi-infinite conductors, you will get more number of numericals in the previous year NEET questions also. If you observe NEET or JEE, let's see here, infinite current carrying conductor. Usually infinite current carrying conductor will be represented like this. A current carrying conductor, if a conductor is represented like this with the current I, if you represent with the dots at the bottom part and top part, this will treat this as infinite current carrying conductor. It is going to infinite length, and the bottom part and top part will represent with dotted lines. Now due to this, at a point P, which is at a distance, perpendicular distance D, if you want to find the field, how we have to do? To understand this, just again try to imagine this finite conductor, current carrying conductor. Due to this, at a point P, while finding the magnetic field at the distance D, we have drawn these lines so that this is alpha, this is beta. Right? So now, if the length of the conductor is increasing, this line goes up. Right? So alpha increases. If length is increases further, alpha increases further. If it goes to infinity, this line will be such that it almost slides or rotates such that this almost becomes what? Parallel to this line or perpendicular to this line. So the line will be like this. So for an infinite conductor, the line joining from top end to this point looks like this. So alpha will be equal to 90 degrees or pi by 2 radians. Similarly, this end also, the line looks like this, because even this line is this point is extending, means the angle will increases gradually, and when this relatively it is at infinity, means this line almost looks like parallel line. So this angle also, beta, also be equal to 90 degrees. I hope it is clear for you guys, right? Now things are clear. As the general formula for finding magnetic field due to straight current carrying conductor is mu naught I by 4 pi d into sin alpha plus sin beta. Are you getting? Right? Here, so alpha is what, beta is what, d is what? Alpha is 90, beta is also 90, d is d only, and it is sin 90 plus sin 90. Sin 90 is 1 plus sin 90 is 1. So 1 plus 1 is 2. Directly you can write 2. So b is equal to mu naught I by 4 pi d into 2, or you can write mu naught I by 2 pi d. Is it clear? Or if you want, just you can write step by step also. I hope it is clear for you guys. It is equal to, b is equal to mu naught I by 4 pi d into sin 90 plus sin 90. So it is equal to mu naught I by 4 pi d into 1 plus 1 is equal to mu naught I by 4 pi d into 2. 2 cancel. So mu naught I by 2 pi d. Is it clear? So this is one of very important case, magnetic field due to infinite current carrying conductor. Next, let us see the next case. Yes, next one, magnetic field due to semi-infinite current carrying wire or semi-infinite current carrying conductor. What is this semi-infinite is? Let us consider this is our current carrying conductor, and this end is going to infinity, extending up to infinity, and this is the finite end, the edge of the conductor. Right? Now, if you want to find the magnetic field at a point P, which is lying towards one of the edge, this is infinite edge, this is the edge we are having, this is a conductor. If you consider, this is the ending point, but it is going to infinity. At this ending point, if you are having the point, then if you draw a perpendicular line to this point, and this perpendicular distance, if it is d, so that when current I is flowing through this at a perpendicular distance d, what is the magnetic field? To find this, same way you have to do. What is that same way is, you have to just, because it is going to infinity, this line looks like, what is that, parallel to this, so alpha is equal to 90 degrees. But here, if you see, this is the point, this is alpha, and this is beta. And here, if it goes to infinity, this becomes 90, alpha becomes 90, beta.
when the here itself fire is ending, means this, if it is here, instead of here, if the point goes nearer to this slowly or gradually, you can say beta is decreasing gradually. If the point is lying exactly on this, the point where the perpendicular line hits the wire, then beta, this line will coincides with, so beta becomes 0. So here beta becomes 0. Is that point clear? So alpha is equal to 90, beta becomes 0, D is D only in this case. So what is the magnetic field? Magnetic field due to semi-infinite current carrying conductor. Semi-infinite current carrying conductor when the point is lying near one of the edge. So here B is equal to mu naught I by 4 pi D into sine alpha plus sine beta, right? So mu naught I by 4 pi D into sine alpha is 90, sine beta is 0. So sine 0 is, so let us write it as sine 90 plus sine 0. So sine 0 is 0, sine 90 is 1. So 1 plus 0 is 1 only. So I will get B is equal to mu naught I by 4 pi D is the magnetic field due to semi-infinite current carrying conductor. I hope it is clear. No confusion, right? Yes, let us see next few examples. Yes guys, now let us see some examples. The question here is, find the magnetic field at point P as shown in figure. Here this is the figure. This is a square loop current carrying conductor. Point P is at the center. So we know for a square, center lies at the point of intersection of the diagonals, right? So a square is having, square means all sides will be having same length, right? If current I is flowing in anti-clockwise direction, what is the magnetic field at P is the question. Is it clear? Yes. Now to find the magnetic field, just if you analyze clearly and briefly, the point P, what you want actually to find the magnetic field due to one straight current. This is considered to be comprises 1, 2, 3, 4 straight current carrying conductors. If you find, and these all are identical ones, that is what you can understand. If you find the magnetic field due to this conductor at this point, including the direction, then you can understand the total field. So here, due to this, if the magnetic field here, if you want to find according to right hand palm rule, just if you stretch the thumb along the direction of current and stretch the fingers onto the point, the direction of palm gives direction of magnetic field. Here also the field, if you stretch the thumb in the direction of current, palm goes in the same direction, and here as well the field will be in same direction. Here also, due to this conductor also, the field will be in same direction. That means total field here due to this entire loop is sum of the fields due to these 4 conductors. So if you find the field due to this conductor, then 4 into that will give you the total field. So you can say total field B total is equal to 4B. If you say conductor 1, 2, 3, 4, 4B1. So here what is B? B is equal to mu naught I by 4 pi D into sine alpha plus sine beta. So what is alpha, beta and D? If you understand, then all things will be clear. Here, to understand this, let us draw a perpendicular line from this. Then if this is D, you know this is A and this is a point of intersection lies at the midpoint, so D is equal to A by 2. Is that clear? And this is usually from perpendicular line, this angle is alpha, this angle is what? Beta. Is it clear? So what is alpha and beta? If you just if you observe here, it is a right angle triangle, right? So angle between these two lines is 90. So this is, here is 90 and this is 90. If you draw a line, a diagonal, this will be, total angle will be how much? 180. So this will be 45. This also how much? 45. So alpha and beta both will be 45 in this case. Here alpha, in this case alpha is equal to, beta is equal to, D is equal to what? Alpha is 45 degree, beta is 45 degree and D is how much? A by 2. Substitute this, you will get B. Then 4B gives total B. Is it clear? Let's see here. B is equal to what? Mu naught I by 4 pi D is A by 2. A by 2 into sine alpha plus sine beta.
it is sine 45 plus sine 45. So sine 45 also you can write, it is equal to mu naught I, this 2 goes to numerator, so 2 mu naught I by 4 pi a into 2 sine 45, 2 sine 45, right, it is equal to 2 mu naught I by 4 pi a into 2 into sine 45, yes, 1 by root 2, very good, 1 by root 2. So depending on the options, again this kind of questions you have to simplify. This further you can write it as 4 cancel, this is 4 cancel, mu naught I by root 2 pi a is the B due to one conductor. Now due to the entire loop, because all are adding over here, total field B total is equal to 4B is equal to 4 mu naught I by root 2 pi a. Yes, sometimes it may be rewritten or simplified in different ways. 4 can be written as 2 into 2 and 1 2 can be written as root 2 into root 2. So this root 2, that root 2 will be cancelled. So you can write it as 2 root 2 mu naught I by pi a also. Depending on the options you have to simplify. Yes, note it down.